begin class today. So we've been doing limits for the last two classes. We already went over a definition of what a limit is, and now today we're basically going to go over some new properties on limits. Okay, so let's start over some basics of limits. Okay, let's start with this first one. Okay, let me raise two of them. So this is the first property we're going to look at, and here's another property. Okay, so let me explain what this one means. Okay, so this is saying the limits of, now this is the function that's coming after the word limits. Now this is saying as x is approaching a, and we went over before that when x approaches a, it implies that it has to be from the left and from the right of a. Okay, so equals c, it's saying the output of the function is going to get close to this value c over here. So let me just draw a picture of what this will look like. Okay, so let's say this is an arbitrary value of a over here, the x value, this is the y values. So this is the constant function. C is constant. So let's just say this is a constant line over here at what this is y equals c, the line over here equals c. So when x is approaching from the left or from the right, this is the function. The function is always the same. It's always a constant, so it's going to approach this value, which is c over here. So that makes sense. Okay, does anyone have any questions on what that means?
No.
No? No one's questions? No one? Okay. Well, let's go on to the next type. The next type of most basic function you can have is x, which is a basic linear function, y equals x. So again, x is approaching some value of a. So let's draw that. Okay, so now y equals x. Does anyone know, could tell me what that looks like in terms of a graph? Anyone know? No one knows? Okay, so y equals x is basically a slope. Y equals x. It's a slope of 1, and the y-intercept is 0. So it goes through the origin, something like this. It forms a 45-degree angle. So if x is a, let's say over here, now you can see the function, what would be when x is a, y is equal to a, so it's going to be the same value. This must be a as well, which is what you get here. So after the equal sign, this is going to be where the function output is approaching. Output. This is going to be the input over here when x is approaching this input. Okay, so these are just two basic types of limits, basically. Two basic types. There's much more complicated ones. Let's just look at a different type. Well, instead of having y equals x, what if we had y equals 1 over x, like the inverse function of x? So let's look at an inverse one, number 3. Okay, let's say we want to take the limit of 1 over x. Or it really could be any constant over x, but we basically want to know when we have x on the denominator, equal, okay, that type of function. So let's say x is approaching 0. Okay, now let's say we have x approaching 0. Let's take the same limit when x is approaching 0. Let's say from the left, and let's look at it from the right. Let's just see what they give us. Okay, now when x is approaching 0, the denominator here is getting very, very small. So we have any number, let's say even 1, dividing by a number very small. So approaching 0 from the left means x is coming from the left of 0, which is like negative numbers, like negative 0.01, let's say negative 0.001, negative 0.0001. It's getting smaller and smaller, but it's still going to be negative numbers. So 1 over a negative number will give us a negative answer. And if you plug in your calculator, 1 divided by some very, very small number, it's going to give you very, very large numbers as the output. So as this gets smaller and smaller, this is going to eventually get to approaching very, very large numbers, unbounded, so it's going to approach negative infinity. This one will be the same thing. Coming from the right of 0, it's going to be, let's say, approaching 0.01, 0.001, 0.0001. It's getting also approaching 0. It's going this direction, but it's going to be from positive numbers. So this is going to give us positive infinity. Okay, is anyone unclear about any of these limits we've done so far? All right, now let's go over the main properties of limits. So these will help us compute limits in general. Okay, let's look over here. Properties of limits. Okay, there are 4 main properties we're going to look at. Okay, the first one, let's take these 2 limits. Let's say we have a limit of function f as x approaches a. So a could be any real number, negative or positive. This is going to give us an output of, let's call it the limits 1, L1. And let's say we have some other function, g of x. It's going to give us L2. X approaches a. Okay, now this has to be the same, x has to be approaching the same value for both of them. And this one gives us an output of L1, this one gives us an output of L2. Now let's look at this limit. Let's say we want to know, what if we add these 2 functions together, f plus g, and also x is approaching the same value of a, plus g of x. Okay, now let's say it's going to be minus 2. Let's say we're adding them or subtracting them. Pretty much they go together. Subtracting is just adding the opposite of the negative number. Now this is going to give us, based on the limit laws, this is going to give us the limit of g. Okay.